Okay. So today we're going to talk about adding, subtracting, and multiplying polynomials. For the most part, it's something you've probably seen before, but it'll be presented slightly differently. So what I've been hearing in my other classes, at least, is this is easy, so hopefully you guys will feel the same. It's a pretty straightforward topic today. So our goal is to be able to, students will be able to add, subtract, and multiply polynomials and read their answers in simplest form. So you may not have heard the word polynomial before. We are going to define that in just a second. It'll be our vocabulary word for today. So we need to know what a polynomial is if we're going to work with it. Like I said, it's something you've seen before, but you may not have heard this fancy math term for it before. A polynomial is an expression using any combination of x's, numbers, and addition or subtraction. That, I gave a concrete example, 3x to the 5th minus 5x squared plus 2x plus 17, that is a polynomial. I could have done any combination. There's an infinite number of polynomials. So I could have said 10x, that's a polynomial. I could have said 15, that's a polynomial. I could have said 7x to the 4th minus 2x plus 100. That's a polynomial. Any combination of letters, well, x's, numbers, and using addition or subtraction. Do you need a pencil right now?
No.
Taking invisible notes today? So if we're going to work with polynomials, William, I swear. We need to know, what does it mean to add and subtract a polynomial? I'm going to pause for a second and still see some people writing before I move to the next page. Yes? Up as in this way? So let's talk about what it means to add or subtract a polynomial. I'm going to switch over now. So to add or subtract a polynomial, it's something you've done before. Basically, adding and subtracting a polynomial is the same thing as combining like terms. Which you've done before in previous math classes. So I gave a couple of terms, 3x squared, 5x, 2x, negative 10x squared. A couple of terms just so we can review which ones are like terms, what we mean by like terms. So when we're combining like terms, we have to have two terms or more, any amount of terms really, just two or more, that have the same variable with the same exponent. That's what we mean by like terms. They have the same variable, and that variable has the same exponent. So if I said 3x squared, and I've labeled these 1, 2, 3. If I say 3x squared, I want you guys to vote which one's the like term, 1, 2, or 3. You're going to hold up a 1, 2, or 3. Everyone needs to be voting. 1, 2, or 3. What's the like term of 3x squared? 1, 2, or 3? Marcel, I don't see you voting. 1, 2, or 3. Which one is the like term? Okay, I see most of you guys holding up a 3, and that would be correct. Negative 10x squared is the like term because it has the same variable x with the same exponent. These two also happen to be like terms, 2x and 5x. Or if we just have plain old numbers, 10 and 7, those would be like terms as well. Numbers with no exponents are also like terms. So let's look at an example. So what's different about this than what you may have seen in the past is each individual polynomial is grouped together in a parenthesis. Mom, Marcel, Michael, please quiet down. So, each individual polynomial, we're looking at example 1 now, each individual polynomial is in its own set of parentheses. Problem is we can't work with stuff, for the most part, if it has parentheses, we want to get rid of the parentheses. So we need some sort of tactic.
Right here. Here we go.
You're here? Again?
Yeah, it's your password that you sign into your computer with. I'm going to pause this for a second. Oh. Okay. So we are talking about example 1. Michael is taking his headphones out. We need to get rid of those parentheses first. Andrew, you too. Let's start taking cell phones. So, oh, crap. Put my marker on the side, and it fell into the trash can. I've forgotten it was there. Okay. So we need to get rid of parentheses. Usually we get rid of parentheses, Marcel, through multiplication.
What?
But I don't have anything to multiply yet. I'm trying to do multiplication. We're trying to get rid of the parentheses through multiplication.
Easy.
So what number's in front of the parentheses?
1.
1. What about in front of these parentheses? 1. So we have a 1 out front that we can distribute in. What's going to happen in when we distribute this 1, though? What happens if I multiply by 1?
Everything stays.
Everything stays the same. Nothing happens. It basically just drops the parentheses. So when it's a positive 1, we can kind of skip the distribution step. But the reason I show the distribution step is because when we have negatives, that's a different story. We can't just skip the distribution step. Marcel, I need your head off your desk.
Why?
So that you can be paying attention.
I am.
Get your head off your desk, please. Okay, William. Face forward. Other William. So we also distribute the 1 in the second parentheses. 1 times 7, still 7. Once again, doesn't change anything. But I show that step because when we get to the negatives, negatives do affect things. So I want to show what's going to happen when we get to the negatives as well. So we need to now just combine like terms. Once we've gotten rid of the parentheses, now I'm just down to what's in common. So if I look at 4x squared, what's in common with 4x squared? 7x squared. We add those together. 4 plus 7 is 11x squared. Then we look at our next term. We have negative 5x. We do keep the sign in front of the term. 5x is one term, and we keep the negative sign in front of the 5x. So negative 5x can combine with positive 8x. Those are like terms because they both have an x with an exponent of 1. It's an invisible one, but they have the same variable, same exponent. So we add those together. What's negative 5 plus 8? 3. And then we combine our last terms, positive 10 and negative 16. 10 minus 16 is negative 6. So again, this is fairly straightforward. Okay, so the only thing different is when we have a negative. A negative value can affect what we're doing. So we have plus sign first, and then we have a minus sign second. That minus sign is going to make a difference. That's why I show the putting the 1 out front and distributing, because it works every time. Kyle, I need your cell phone, please. Thank you. For today, you get it back. If I have to take it again, I'll take it to the office. So example 2. Same thing. We can put a 1 in front of every parenthesis. We know when I multiply a positive 1 in, it's not going to change anything. So the first two, we know, are not going to change. We multiply by a positive 1, same thing. Anytime you multiply by a positive 1, nothing changes. When we multiply by a negative 1, that's a different story. It will change things. It's not going to change it in a huge way, but it will change it. So when I multiply by a negative 1, what's a negative 1 times the positive 6x squared? Negative 6x squared. So it's going to change the sign of everything. Negative 1 times 4x is negative 4x. Negative 1 times negative 3 is positive 3. So when we have plus signs, we can ignore the parentheses basically. But when we have minus signs, we have to change the sign of everything inside. Marcel, will you go move over to Dylan's table for today? Marcel, will you move over to Dylan's table for today? Dylan, right there. He's back in the white sweater. Let me point it out more specifically for you. Will you move to this chair right here? Thank you, Marcel. So now we just combine like terms. Once we've gotten rid of the parentheses, we're ready to just combine like terms. We have 5x cubed plus 8x cubed. That gives me 13x cubed. Now when we're gathering our terms, usually we read left to right, but technically we need to go in descending order. If I have x cubed first, I need x squared second. I need my exponents to go down in the order. Yes?
How'd you get 13?
Okay. If we have a 5x cubed and an 8x cubed, when we're combining our like terms, we just add the numbers in front. So 5 plus 8 gives me 13. Okay? Good question. So now we combine our squared terms. 2x squared minus 6x squared. Once again, we're combining the numbers in front. So 2 minus 6 because that 6 has a negative sign. So negative 4x squared. Then I get just my plain old x's. I have negative 1x and negative 4x. So that gives me negative 5x. And then just our plain old numbers, negative 9 plus 3 is negative 6. Now, I'm not going to dock you points if you don't put it in descending order. It just looks unnatural to me if you don't put it in descending order. So, I mean, technically they're the same thing, but this is the acceptable way to write it. Yes?
How'd you get 4?
This one? Okay, we had a 2x squared and a negative 6x squared. So we're doing 2 minus 6. If we're subtracting, we subtract big minus small. 6 minus 2 is 4. But we keep the sign of the bigger numbers. 6 is bigger, so we keep the negative sign to make a negative 4.
6 minus 2 is so just minus 6 from 2.
6 minus 2 is technically positive 4, but at this point, most of the time
How'd you get 6 then?
2 and then minus 6.
it's just part of the problem. They gave it to us.
Oh.
Okay? So I want you guys to try this problem, and then we'll talk about multiplication. Okay, so let's look at this problem, and then we'll talk about multiplying. So on this try problem, the first one is a positive one, so it's not going to change anything. So when there are negatives, I would recommend rewriting on a second line. Because even though the first one doesn't change, the rest do. And you're going to be liable to forget that the rest have changed if you don't write it out a second time. So then these ones, when we multiply by negative 1, it changes the sign of each one. Instead of positive 5, negative 5. Instead of positive 8, negative 8. Same thing here. It's going to change the sign of everything. Instead of positive 10, negative 10. Instead of negative 3, positive 3x. Instead of positive 4, negative 4. And now we just look for our like terms. We combine our like terms. What is 3 minus 10? Negative 7. Be careful with your subtraction and working with negative numbers. If you need to, use a calculator so you can be sure that you're subtracting these correctly. And then 5x to the third, it has nothing to combine with, so we just bring it down, negative 5x to the third. Then we have negative 2x squared, negative 8x squared, negative 2 minus 8 is negative 10x squared. 7x and 3x, add those together, we get 10x. And then again, negative 4 has nothing to combine with, so we just write it down. And again, if you put these in a different order, that's okay, I'm not going to mark it wrong. I might screw up a couple of times and look at it the wrong way, so I might make mistakes on, on your homework and cross it out and then scribble out my cross out, because this is what I'm used to looking for, is this order. But they will not technically be wrong if you don't put it in this order. So let's talk about multiplying polynomials. Once again, this is something you've probably worked with before. Just like combining like terms should have looked familiar, so should multiplying polynomials look familiar. And if you want to sit like here for the screen better, you don't have to stick to just that chair. So multiplying polynomials. Once again, it follows different rules than adding and subtracting, just like when we worked with radicals. If we are multiplying a polynomial, we times the coefficients and add the exponents. Multiplying polynomials follows different rules than adding and subtracting. So what do I mean by a coefficient? If I write a term up here, let's say I have 3x to the 4th. Which number is my coefficient? 3. The number out in front, the math term for it is coefficient. So that leaves 4 to be our exponent, which we've worked with recently when we did our exponent properties. Sorry, that word got kind of smushed. So when we multiply coefficients together, add the exponents together. Again, it's something that hopefully you have seen before. You should have seen similar things in previous math classes. So looking at example 3, we have 5x to the 5th times negative 2x. 5x to the 5th times negative 2x. So according to my instructions, we multiply the coefficients. Which two numbers do we need to multiply together?
The 10 and the negative 2 would equal negative 10.
The 5 and the negative 2 equal a negative 10. Okay, so those we multiply together. And then we add the exponents. So 5 times 2 gave us negative 10. We're still going to have an x. And we did get a 6 because what's the exponent on this? 1. Divisible 1. So 10x to the negative 10x to the 6. Again, fairly straightforward. The processes today are pretty darn straightforward. The only thing that might be different is the amount of things you're multiplying. I could also multiply something like this. Now instead of multiplying just one thing, we're going to have to distribute to both. We have to multiply that 2x twice. 2x times 3x squared and 2x times negative 10. We have to multiply it by both things. So we're distributing this in. Now I'm going to write in kind of our mental step. It's something you don't actually have to write down when you're doing the problem, but just this is what we're thinking as we're working through this problem. First we're thinking I have to multiply 2 times 3x squared. Then we're thinking I have to multiply 2x times negative 10. So again, this is more of a mental process. This is what we're doing at this moment in time. But when you actually go to do the problem, you're probably not going to write that down. It's just what we're thinking right now. So we're thinking, okay, I'm multiplying 2x times 3x squared. I multiply the coefficients together. 2 times 3 is 6. I add the exponents together. X to the first, so 1 plus 2 is 3. So then we do our second multiplication. 2 times negative 10 is negative 20. If your answer comes out negative, we just write 1 minus sign. If it comes out positive, we write 1 plus sign. And then the x had nothing to combine with, so we just write it down on the next line. So we just have 2 more examples and then we'll be done with notes for today. And you'll probably have about half an hour's work on your assignment today. So if you work and you are focused, you might be able to finish your assignment today and not have any homework tonight. So now we have, again, more things we're multiplying. The only difference with multiply is how many times you have to multiply. Now, the process we use to multiply this out is called by a couple of different names. Your teacher may have called it FOIL in the past. Your teacher may have called it the rainbow method in the past, or the claw method in the past. Those are just the names to help us remember how to multiply this out. But it's basically still just distribution. You just have to distribute a couple of times. So we have to distribute this 2x to everything in the other parenthesis. It can only ever interact with the other parenthesis, not with its own parenthesis. And then we have to multiply the negative 5 times everything in the other parenthesis. And again, your teachers may have called it a couple of different things. FOIL for first times first. 2x times 3x is first times first. Outer times outer, inner times inner, last times last. Rainbow method, because it kind of looks like a rainbow. Or claw method, because if you look at both parts, it's kind of like a claw. So, a couple of different names just to remember how to multiply it out. Kayla, I have your cell phone. So we multiply 2x times 3x. This time I'm not going to write the mental step. We're just going to go straight through the problem. 6x squared. 2 times 3 is 6. We have an x to the first times an x to the first, so 1 plus 1 is 2. We multiply the next one. 2x times 2, 4x. We multiply again, but now we're working with the negative 5. We do negative 5 times 3x, negative 15x, negative 5 times 2, negative 10. And now, if there are any like terms after you've multiplied, we do need to combine them. We are not in simplest form yet, because we do have some like terms in this expression. What like terms do we have?
4x and
The 4x and the negative 15x. So we just bring 6x squared down. We combine those together. 4 minus 15 is negative 11x. And we just bring the negative 10 down.
So 4 minus 15 equals -11.
Yes. I always want it to be negative 9 for some reason. But it's negative 11. Because if we did 15 minus 4, 15, 14, 13, 12, 11. Okay, so last example. And then we'll get started on the assignment. So again, it's all about distribution. Anytime we have parentheses, we have to distribute that outside number. We're just, again, going to have to distribute it a lot more times because there's 4 terms inside. We're, again, going to have to multiply 4 different times. And it doesn't matter that 5 doesn't have a variable with it. It still can multiply by everything inside. So that's another reason why it may be called rainbow method. That one looks more like a rainbow since we have so many curved lines. So now we just multiply. 5 times negative 3. Negative 15, we leave x to the third because the x's didn't have anything to interact with. We leave them alone if it doesn't have anything. Since 5 didn't have an x to combine with x to the third, we leave it. 5 times 2. Positive 10. 5 times 5. 25. And 5 times negative 7. Negative 35. So again, a fairly straightforward process today. There's not a whole lot of tricks and weird things that happen with it. It's all about combining like terms or distributing.